Vitamin B12, or cobalamin. How does B12 affect the body? First, we'll start with the B12 functions. The top three major biological functions in the body. B12, or cobalamin, functions as a cofactor for the enzyme methionine during synthesis, where it will provide a methyl group for synthesis, which is necessary for DNA and RNA production and function. This, in turn, helps epigenetic control of gene expression and the maintenance of the genomic integrity. B12 also plays a large role in metabolism as it functions as a cofactor for the conversion of L-methylmalonyl-CoA to succinyl-CoA during the TCA cycle. It aids in breaking down propionate, which is a short-chain fatty acid. In a similar sense, B12 is vital for the synthesis of red blood cell production. Vitamin B12 is the main component in the production of heme, which is the main component of hemoglobin in all red blood cells.
Alright, I'm going to talk about digestion and absorption of vitamin B12. So in the mouth, the salivary glands produces R protein that will travel to the stomach and bind with vitamin B12 there. Now in the stomach, the cells lining the stomach wall secrete HCl, pepsin, and intrinsic factor. HCl and pepsin releases vitamin B12 from proteins in the food, and the intrinsic factor travels with chyme into the small intestine. After vitamin B12 has been released from food proteins, it binds with R protein and moves into the small intestine. Now, in the small intestine, just real quick, in the pancreas, the pancreas releases pancreatic proteases into the small intestine, and then in the small intestine, the vitamin B12 then binds to the intrinsic factor and travels to the ileum, and then in the ileum, the intrinsic factor binds to the receptor side in an intestinal cell, and then releases the vitamin B12 into the cells. Alright, so now I'm going to talk about the most common reasons for deficiency. So one reason is just not eating enough vitamin B12 rich foods. So as we know, a lot of vitamin B12 are found in animal products. Therefore, it's very common for people following the vegan diet to not have enough vitamin B12, and especially if they don't consume vitamin fortified foods or supplements. Another reason for vitamin B12 deficiency is malabsorption, and there are 4 reasons for why that is. One being the lack of HCl. So HCl is a protein complex in the stomach, and an inadequate amount of HCl impairs the body's ability to break apart vitamin B12. Another reason could be insufficient pancreatic enzymes. So when the pancreas does not produce enough enzymes, the body has trouble hydrolyzing the B12R protein complex in the small intestine. Another reason for malabsorption is gastric bypass surgery. So gastric bypass surgery is a weight loss surgery, which involves creating a small pouch from the stomach and connecting it to the small intestine. So it kind of like rerouting a little bit, like changing the natural course of digestion and absorption. And here it's a smaller stomach, so which means less food consumed and less digestion, and which means less absorption of nutrients, which includes vitamin B12. And lastly is pernicious anemia. So pernicious anemia is a form of microcytic anemia, and there's a lack of sufficient intrinsic factor to release vitamin B12 to release the B12 in foods. There's enough folate, which is also vitamin B9 available, which kind of works with vitamin B12. But there's enough folate available for red blood cells to divide, but folate is trapped as 5-methyl-THF and can't be used properly.
Vitamin B12 deficiency can be a serious health issue. The top 3 effects of vitamin B12 deficiency are medioblastic anemia, low counts of white blood cells, red blood cells, and platelets, and glossus of the tongue. In people who are pregnant or breastfeeding, vitamin B12 deficiency can cause neural tube defects and developmental delays in the fetus, and also failure to thrive and anemia of the infant.
So I'm going to talk about vitamin B12 toxicity and its effects. So reaching toxic levels of vitamin B12 is actually pretty rare because it's relatively harmless even at high doses, and the body only absorbs what it needs and the rest is excreted in urine. But sometimes if B12 is given to treat diseases like liver disease or deficiencies, it can have side effects like headache, nausea, vomiting, fatigue, and weakness.
Vitamin B12 can have interactions with certain medications. These medications include gastric acid inhibitors and metformin. Gastric acid inhibitors are used to treat esophageal reflux disease and peptidic ulcer disease. They can interfere with the absorption of vitamin B12 because they slow down the release of gastric acid, which is essential in the absorption of B12. Metformin is another medication that vitamin B12 interacts with. Metformin is an anti-hyperglycemic agent used as a first-line treatment for prediabetes and diabetes. The use of metformin can reduce the absorption of vitamin B12 and significantly reduce serum levels of vitamin B12.
B12 food recommendations. So some common food sources of B12 include 3-ounce beef liver, which is commonly found in Eastern European cultures and cuisines and is less likely to be found here in the States. It has the highest quantity of B12 at 70.7 micrograms. 3 ounces of clams without shells will provide 17 micrograms. 1/4 cup of nutritional yeast, fortified, can provide 8.3 to 24 micrograms, and this is usually used as an adjacent to seasonings and flavorings in soups and snacks. 3 ounces of Atlantic salmon cooked can provide 2.6 micrograms, and 3 ounces of canned tuna can provide 2.5 micrograms of B12.
Now we are going to look at the different forms of vitamin B12. Ways to get B12 other than dietary sources include multivitamins, fortified breakfast cereals, oral supplements, dissolvable supplements, and in extreme cases, injections or nasal spray prescriptions are available. B12 is typically absorbed best when taken with other B vitamins, such as vitamin B6. Magnesium also helps with B12 absorption.
UL value doesn't exist for vitamin B12. Reaching toxic levels of vitamin B12 is very rare, so the Food and Nutrition Board has not set a UL value. Additionally, vitamin B12 is a water-soluble vitamin, so any excess consumption can be removed from the body easily.
Now we will look at the DRI value for adults. This value is 2.4 micrograms per day. Examples of how to meet these values consist of eating a wide variety of animal products, such as fish, meat, poultry, eggs, milk, etc. It's very hard to meet the daily values for B12 through only a plant-based diet. Specific food quantities include 1 large cooked egg, which is 1/2 of a microgram, 6 ounces of plain fat-free yogurt, which is 1 microgram, or even 3 ounces of cooked salmon, which will give you 2.6 micrograms.